Okay, so good day everyone. This is your Physics 2 last long quiz solution for the multiple choice. Number 1, we have two uncharged conducting spheres A and B are held at rest on insulating stands and are in contact. A positively charged rod is brought near sphere A as suggested in the figure. So this one. While the rod is in place, someone moves sphere B, the larger sphere, from A. How will the spheres be charged? So the answer for this one is letter C, and the reason is that, again, if you place the positively charged rod near sphere A, the smaller sphere, the electrons present, the freely moving electrons present in sphere A will tend to move on this side of sphere A. So thus, this will leave this side to have this net positive charge, this side only. Now, since this one, the charge here, it will have more positive charges here. It will attract also the freely moving electrons in sphere B. So again, electrons present, the freely moving electrons present in sphere B will also tend to move on this side. So thus, if you remove or if you move sphere B afterwards, it will leave sphere A to have this net negative charge, and also sphere B to have this net positive charge. Again, sphere A will have this net negative charge, and sphere B will have this net positive charge. Again, the charges cannot flow towards the ground because, again, this is insulated. The stand is insulated. So thus, the electrons will stay in the sphere. Okay, so that's the reason. So number 1 is letter C. Okay, for number 2, how many electrons flow through a battery that delivers a current of 3.0 ampere for 12 seconds? So the answer for that one is letter E. We have 2.2 times 10 to the 20. So that's the number of electrons. So the solution for that is, again, first we start here. So this is the equation for the current. So the amount of charges over the span of time that flows. Again, the interpretation of this equation is that it's the amount of charges that flows through this imaginary surface for a specific period of time. Okay, so again, if you rearrange this equation, we have change in Q is equal to I change in T. So we know that the change in Q, or the amount of charges, is just equal to the number of charges times the fundamental charge. So in this case, the electrons, since again the electrons is the one that flows through the wire, so the fundamental charge is the charge of the electron. So the charge of the electron times the number of electrons. So that's the amount of charge. So again, the problem here is that we need to find the number of electrons. So again, we divide both sides by the fundamental charge. So again, we will arrive at this form of equation. So N is equal to I, a change in T, over E. So if we substitute all the values, so we have I, 3, the time, 12, and E, 1.6 times 10 to the negative 19. So then we'll get the total number of charges. So we have 2.25 times 10 to the 20, or approximately 2.2 times 10 to the 20. So therefore, the answer for number 2 is letter E. Okay, for number 3, an electron traveling horizontally enters a region where a uniform electric field is directed upward. What is the direction of the force exerted on the electron once it has entered the field? So the answer for number 3 is letter D, downward. The reason for this is that, again, this is the direction of the electric field. Again, the electric field is uniform. That means the electric field anywhere in this anywhere in this box, right, this region, will have the same magnitude of electric field. Okay, so again, as this electron moves towards this region, the force that is exerted due to this electric field will be opposite with respect to the direction of the electric field. Because again, if we have a positive charge, the direction of the force exerted by this field to this positive charge particle is the same direction with respect to the direction of the electric field. But if it's negatively charged particle, then it will be opposite. So meaning, as this negative charge particle or electron moves through this uniform electric field, the direction of the force that will be exerted in this negative charge particle is opposite. So therefore, the tendency of this negative charge particle is to move opposite to the direction of the electric field. So thus, as this particle moves through the electric field or through this region, its direction will be towards the opposite direction, or it will have this downward direction of movement. So that is why the answer for number 3 is letter D. So the tendency of this negative charge electron is to move downward, because again, the direction of a negative charge particle, or the force that will be exerted on a negative charge particle, is opposite to the direction of the electric field. If it's positive charge particle, then it will have the same direction with the electric field. So it will tend to move with in the same direction of the electric field. If it's positive charge particle, but if it's negative, it will tend to move opposite to the direction of the electric field. Okay, for number 4, we have this one. The potential difference across the ends of a wire is doubled in magnitude. If Ohm's law is obeyed, which one of the following statements concerning the resistance of the wire is true? So the answer for letter A, and for number 4, is letter A. The resistance is not changed. So again, this is the other form of Ohm's law. So if you're going to solve for the resistance, so we have V over I. So again, if we try to increase the voltage, or the potential difference, so the other term for voltage is the potential difference. So if we try to increase the voltage or the potential difference, that will also result to an increase in current. So therefore, the ratio will stay the same, and thus the value for the resistance will not change, because again, as you increase the voltage, it will also increase the current. So the resistance will not change. So therefore, the answer for number 4 is letter A.